So in this video, let's talk about number 18 on test 3 review under exponential equations. This one, I know it's exponential because again, my variable is trapped in the exponent, but there is so much other stuff going on here. Notice we have a multiplier of 6 on the outside of these parentheses, and we have a plus 8, and then of course it's equal to 128. The best way I can think of this problem is, of course, this is what's making it more complicated and a little bit more intimidating. So, you know, for the sake of us having some dialogue real quick throughout this video, I'm going to go ahead and I'm going to replace this drama right here. I'm going to tell you off to the side. Every place I have 10 to the x plus 1, I'm going to temporarily replace it with a heart, and we're going to talk about it. So if I had 6 heart plus 8 equals 128, and I said solve for heart, I'm hoping, you know, when you saw this, you'd say, oh, if I was trying to solve for heart, I would subtract 8 from both sides, and then that would give me 6 heart equals 120. Then I would just divide by 6, and I'd have heart equals, what is that, 20? And that would be the answer for that problem. But this one's a little bit more complicated, but you get this same idea. So you want to isolate this drama right here, get that all by itself, and then we'll see where do we go from there. So we can kind of ignore that. So let's talk about that. We would subtract 8 from both sides. So I would have 6 open parenthesis 10 x plus 1 still on the left hand side. This is gone now, and that's going to equal 120. Then I would divide both sides by 6, and I would be left with 10 x plus 1, because these would cancel out, equals 20. So I'm feeling pretty good about that. There kind of resembles what we just got finished doing on the side. But I would definitely see, can I make my bases the same? And I can't. 10 to the 1 power is 10, 10 to the 2nd power is 100. And so not possible to make our bases the same here. So then we're forced to rewrite it, and that would give me log base 10, but I don't need to write that, so I'm going to write it kind of small, to the 20 equals x plus 1. There's an implied 10 there, so you don't need that. Then I would subtract the 1 log of 20 minus 1 equals x. And once again, this simply becomes a calculator problem. And frankly, you don't even have to use the change of base, my few people that have an older calculator, because your calculator, whenever you push the log button, automatically knows that that is the base 10. So here, this is, I frankly think this one's a little bit easier. It was just a little bit more complicated at the beginning. You would just hit the log button, and you would put 20 in the parentheses, close parentheses, minus 1, and hit enter. And there's your answer. So my answer is x equals 0.3010. And that's your answer. Let's move on, since we're moving through these pretty quickly. Let's look at 19. So 19, once again, is exponential because the x is trapped in the exponent. And we're moving through this process the same as the last problem. We want to isolate whatever has that. We want to isolate whatever has that exponent. And so in this case, I'm going to add 9 to both sides. So I get 7e to the x equals 103 plus 9, and you get 112. Then I'm going to divide both sides by 7, and I get e to the x equals 16. So take that in for a minute. Again, if it was possible to get this 16 to where it had the same base as e, that would be awesome, but not the case here. So we would rewrite it natural log. Why did I choose natural log and not log? Because I have a base e, and natural log has an implied base e. So it'd be natural log of 16 equals x. And once again, this just becomes a calculator problem at that point, because you already have a natural log button right here. And so you just hit that. It'll let you have parentheses, put 16 in, and hit enter, and there is your answer. 2.7725, 2.7726 if we're going to round to the 4th place. And that's your answer. Let's power through and look at number 20. So we have 10 to the 0.0098x equals 205. And I definitely want to keep 20 and 21 in this video together because they look so strikingly similar. Can't make my base the same, so I need to move on and write it as log. Again, there's an implied 10, which is the same as this base. 205 equals 0.0098x. divide by 0.0098, 0.0098, and now again, this is simply a calculator problem. But I haven't shied away from showing you how to use the calculator, and I expect y'all to be following along with me so that you can gain practice here. And so we're doing, let me kind of shift this over a little bit, we're doing this right here. So hit your regular log button on the outside because you don't need a base, it implies base 10, 205, close parentheses, and then hit divided by 0.0098. And that's my answer. So let me copy that down. 235.8932, if we're working on rounding to the fourth place value. So now let's go ahead and stay on this topic because 21 is just like this. So it's a little bit longer video, but well worth it, I feel. So let's look at 21 for just a second. Let me bring it down here. Do you see the strikingly familiar setup? This one had a base 10. This one has a base E, but everything else is exactly the same. So we're going to handle it accordingly. I can't make the bases the same, but now instead of writing log, I'm going to use natural log because that has an implied base E. So it's natural log of 205 is equal to 0.0098x. You're still going to divide by 0.0098, and then this one, you're not going to hit the log button, you're going to hit natural log, but we're going to watch something kind of interesting happen here. Natural log of 205 divided by 0.0098, and different answer. Why would that be? Well, remember you have a base E, which is like pi, where it's just a reoccurring decimal, irrational number that never ends and never has the same pattern. So that's much different than using a base 10. So know the difference. So this is 543.1643 is the answer for this one. Let's go ahead and wrap up in this video. I know it's going to be a little bit longer. Number 22 of exponential equations. So again, kind of complicated here, but hopefully by now you've gotten much faster at this. The variable, the x is trapped in the variable, so I need to isolate. So I would divide both sides by the 3,000. So I get 1.09 to the x power equals 3,600 divided by 3,000, and you get 1.2. As tempting as it is to divide by 1.9, it's not possible because remember, this isn't a multiplier, this is an exponent. So what's the only way to free an exponent? Rewrite it in logarithmic form. So this is log, but my base is now 1.09 to the 1.2 of 1.2 is equal to x. And you're going to put this in your calculator. Newer calculators put it exactly how you see, but don't forget to put the math button where it has that log of a base. My older calculators, you're going to use your change of base formula. So let's go ahead. This would be log, we'd have to go to math, go up. So this would be log base 109, open parentheses 1.2, and hit enter, and you get 0.0389 equals x. If you're using the change of base formula, remember that's log of 1.2, let me see if I can get my screen, divided by log of, wonder if I did that one wrong, 1.09. I think I put it in. I'm looking back at my work over here. I don't know if you noticed I forgot to put my decimal. So that's the true answer. So let me show you kind of a neat trick. I can go second enter, will bring back my last thing, and then I can go second enter again, and it brings back. And so now I can simply go in here and then I could hit second insert, and it'll let me be able to put that decimal. And now hit enter. Oh, that's interesting. I think I did my change of base.